Hello, my dear ones. Now let's look at the turning points on polynomial functions. This is the second part of the lesson for characteristics of polynomial functions. We are going to learn the extrema, which are also called the turning points. Okay, so let's look at this. The points at which a polynomial switches the direction, right? Those are called turning points. This is like a layman term. Normally, they are together called extrema, and we'll see in a bit. If the turning point, so if you see here in the graph, this is the graph going up from the x side to the, left side to the y side on, the left side to the right side on the x-axis. You'll see that the graph is going up and changing its direction at this point, right? And coming down, and again changes its direction at this point and goes up. So these 2 points are called the turning points. If the turning point is higher than any other nearby point, right, it is called local maximum. Normally a relative, let me actually go for a thinner pen. This is called a relative or local. Both words mean the same, maximum. If the turning point is lower than any other nearby point, it is called the relative or local minimum. And these maximum and minimum values together are called extrema, because they are the two extremes, right? Extrema. So these actually help you define where the function is increasing, from where to where. In this particular graph, it's increasing here and here, and where the function is decreasing. So the graph is decreasing from here to here. Right? So this is really important. And how do we know that? Normally, if they're given, if the coordinates are given, then they are good to go. But to find these coordinates first, we need to actually graph them on the calculator. Or, better still, you can go to the Desmos. But what if you're not allowed to use your computer? Then you would actually go by the good old way using the calculator. Let me quickly increase the size of this window so you can see the full calculator. Just hold on. Okay, so this is the calculator. We'll quickly enter this x cubed plus 5x squared minus 8x minus 1. Okay. Oh, my bad. I should be doing that on the y equals, oopsies, x cubed. Here we go again, plus 5x squared minus 8x minus 1, right? So if you look at the graph, this is what you get. Okay, so with the window that is set for, it's usually the minimum is for the y values is negative 10 to positive 10, which means that the graph is going beyond positive 10. Okay, so we need to know where. We don't really have to change the window size for this. We can actually know the highest point and lowest point using the calculate feature of the calculator. You would do second and trace and then move yourself down to the minimum position first, because that's where it is, the first thing. So now it'll ask, where is the left bound of the minimum point? We know that it is right here. So the cursor is already placed on the left side of the minimum. So I would say, okay, that's fine. Let's take that as a left bound, the left side of the relative minimum. And then now it is asking us to move the cursor. Where is the right bound of that point that you want to find? So I'll move the cursor to the right side of the minimum point and say enter. And it says, should I guess? And I would say, yes, please guess the value. And you will get the values right here. Okay, you'll get the values right here. And so you would repeat the process for the relative maximum. So you would do second and trace. You would go to the fourth option or directly enter 4. Now it is asking for where is the left bound. So you have to, you know that the cursor is now placed here. It's flashing there. So you have to keep it going and you have to be patient until it goes up and comes down to the left side of the maximum point. Okay. Be patient. Oops. Now this has its own mind. Okay, so there you go. You see that? So it's right here. So we'll say, hey, okay, this is the left side. And now we'll move it to the right side. Sometimes the graphs are not that bad. We can actually see them fine within the window. You could definitely change it, but the point, you have to do this anyway. I can see flashing there. So I will say, okay, this is the right side. Yes, please guess, and it will give you the values here. Okay. If you have the calculator with you, you do this. Or if you don't, you can actually go to the Desmos. I have already entered this for our reference, and you can just say, you can see the lowest point is right here. And if you actually move the graph, you can absolutely see here what is the maximum point. So let's note that down on our graph here. So we'll just write down what is the relative maximum. We found that it is -4 and 47. I'm taking the Desmos values. And the relative minimum is 0.67. I'm rounding it off to the hundreds and here to the tenths. Okay. So now that I'll just generally draw so I don't have to go back and forth. It was way up high and somewhat like this, isn't it? So this point is -4 and 47. And this particular point is 0.67 and -3.8. So now we can actually see where is the graph increasing. As I was telling you earlier, the graph is increasing this way and this way, right? So it is increasing from negative. So you are actually thinking of going from left to right on the x-axis when you're writing these intervals. Okay, so keep that in mind. So from the left side, the graph is actually increasing. So from -infinity up until the x value of this point, which is -4. So from negative infinity to -4, it is increasing, and you want to always use open intervals for this. And for the next part, from here to here, there are two parts where it is increasing, isn't it? So from here, the minimum, the lowest point, to infinity again, right? So that is from positive 0.67 to positive infinity. So you would say a union because you are actually combining two things here. So 0.67 to infinity, it is still increasing. Okay. Now we'll look at the decreasing intervals. So this is where the graph is decreasing from here to here. So which means from -4 to 0.67, the graph is decreasing. My bad, I should have written 4 instead of 0. So -4 to 0.67, the graph is decreasing. Okay, again, open intervals. So yeah, so this is it. This is how you would find the relative maximum, relative minimum, and also using those turning points, we're actually defining where the graph is increasing or decreasing. Okay, I hope this helps. Please join me in the Math Excel help video. Thank you so much for watching. Bye.